Hi, folks. We're going to do variable expressions and equations. This is section I from the Algebra 1 IXL. And we're going to write variable expressions. This is basically converting standard English into algebraic notation. So the really nice thing is that they give you a lot of tools in order to do this. I'm going to show you the examples and work them out for you. So we're going to write variable expressions. And we want to take C divided by 7. Now this happens to be in order, so I'm going to just take C and divide it by 7. A lot of people want to use the division symbol, but don't use that. Actually write a fraction. That is much better in algebra to use the division line. You could use divided by using the slash, but it's much better. Instead of writing this, for example, instead of doing this, it's better to write them straight up and down, because then it's clear which one is in the numerator and which one is in the denominator. Now, it doesn't seem like it's a big deal until you get to something like this. X over 2 plus 5 is different than, which is different from. And you need to know which one you're talking about. So these are, this is a much better way to write things instead of this or this, because it makes it clear which one is happening where. So write straight up and down. In the IXL, they give you the little, they give you this fraction bar that you can use. So it's much nicer. So anyway, there you have it. D divided by W. This is W over 4. 4 over W. 4 divided by W. Now, some people are going to want to write this. Not a good idea. Again, I don't recommend this one. I recommend using, good question in here. Here we go. This one, W, 4. Keep saying that, 4 divided by, get in there, W. Now we've got write an expression for W, raise W to the 9th power. Well, that means that you're going to take W and raise it to a power. They give you this little raise to the power button, and I'm going to raise it to the 9th power, which means multiplying W times itself 9 times. The difference of 3 and Y, the and indicates where the operation goes, and the difference tells you that it's subtraction, so it's 3 minus Y. Subtract 4 from T. This is a very common mistake. A lot of students get this backwards. You're supposed to take 4 away from T. So you're taking the T and subtracting 4 from it. This one says divide J by 9 and then add K to the result of the J divided by 9. So we're going to take J divided by 9. Let me get rid of this for a second here. There we go. So that I'm using my, let's see, and then add K to the result. So I'm going to add K. Raise A to the 7th power, then divide B by the result. Now, order matters. You need to take B and divide it by the result of A to the 7th power. So the B is in the numerator. And the a to the 7th power is b is being divided by that. So in the denominator, we have to put a raised to the 7th power. Raise g to the 10th power, then multiply the result by f. So you're going to take g raised to the 10th power. Notice that I'm using the key that, but be careful. You need to make sure that you go down to the main area, and then you can multiply by f a number of different ways. You can multiply by f by putting it in parentheses, or you can use the little dot key, which means that means multiplication as well. I could have just as easily done parentheses and put the f in parentheses. Either one is correct. Divide 5 by r. That means 5 divided by r, then multiply 10 by the result. So really, let's do this in the right order. It says to take 10 and multiply it by 5 divide 5 by r. That would be 5 over r. It says multiply 10 by the result of this multiplication, divide 5 by r. Raise 6 to the 5th power, then find the sum of the result and a. So I'm supposed to take 6, raise it to the 5th power, and then I have to find the sum of the result and a. By the way, 6 raised to the 5th power is not 30. It's 6 times 6 times 6 times 6 times 6. It's a very large number. It's around 180,000, I think. So watch out for that. That does mean something. Those exponents do mean multiply. Subtract the quotient of 2 and t from 7. I'm glad this one came up. The quotient, the sum, product, and difference really should always be put inside parentheses. Very important. And there's a reason. We're going to subtract the quotient of 2 and t, which is 2 divided by t. And we're going to subtract that from 7. So the 7 is what we're going to start with. And from 7, we're going to subtract the quotient of 2 and t. Now this is really wrong, because it's a really good idea to always put quotient, product, sum, and difference inside parentheses. In this particular case, it isn't going to affect our answer, but it could very much do that. So a good practice is to make sure that that second part, oh shoot, I messed up. Sorry about that. Let me see if I can put, looks like I have to put the parentheses first. So it is better to put parentheses around any time you see product, quotient, difference, or sum. Then I put the 2 and t, 2 divided by t. Now, in this particular case, it really didn't matter, but it's a really good habit to get into. Let's see if they allow it on the program. They may not. Yeah. Raise the difference of 6 and v to the 3rd power. In this case, if you don't put the parentheses, you will get it wrong. So the parentheses surround 6 minus v. That's the difference between 6 and v. Then I have to raise that whole thing to the 3rd power. That means 6 minus v times 6 minus v times 6 minus v. T plus the difference of 2 and 8. Very nice. If you don't put the parentheses, it is very possible to get it wrong. In this particular case, it actually works. without the parentheses, but it's always better to do it. T plus parentheses 2 minus 8. This is the correct way to write that expression. Subtract 3 from D. That means D minus 3. It's really easy to get that wrong. Then double the result. When they say the result, it's really assuming that you're in parentheses. So watch out for that, okay? So we're going to subtract 3 from D. So that's going to go in the parentheses. D from 3, 3 minus D minus 3. It's really easy to get this backwards. I'm going to take 3 away from D. Make sure you read it and make sure it's correct. Then I'm going to double the result. Now, there's lots of ways of doing that. You can multiply by 2. Because the parentheses are there, it's assumed multiplication there. And to double the result, I could have also multiplied it in the other order, 2 times the quantity D minus 3. If the parentheses aren't there, it is wrong. Add V to the sum of U and T. So basically, you're supposed to take the sum of U and T, which it assumes parentheses there, and then we are going to add V to it. That means adding V. Double the product of G and H. So you're supposed to double, which means multiply by 2, the product. The product means, again, it's a result of a multiplication. So it's G times H. One way to write G times H is just to write them next to each other. You could have put them inside parentheses. You could have put a dot between them. Either one is correct. The most simple version of this is 2GH, but it's better to always put product, quotient, sum, and difference inside parentheses, okay? Because those are the results. It just ensures that you do that first. 6 more than the product of K and 8. I really wish that IXL would not count it correct if you do it out of order, because it really says that you're taking the product of K and 8 and you're multiplying them together, and then you're adding 6 more to it. So this literally says K plus 8, and then we are going, K times 8, my bad. Let's see. K, we usually write it as 8K, or K times 8 is in the correct order. So I'm going to write K times 8. So the product of K and 8, and we want to go 6 more than that. That means plus 6. Now, a lot of people are going to write this the other way. They're going to say 6 plus the product of K and 8, which will still be correct mathematically. But if that had said difference and you write it out of order, it'll be wrong. So if this had said the difference, it has to come first. In the parentheses. Are decreased by the difference of S and T. In this particular case, you're taking R and you're decreasing it by a difference. A difference means parentheses. It's the result of a subtraction, S minus T. Add the quotient of 2 and D to C. Now, the way that this is written, you really should take C and then add the quotient to it. The quotient must be in parentheses, or should be. So I have C, and I'm going to add the quotient, which looks like this, of 2 and D to C. Add the quotient, which is in parentheses, 2 divided by D, to the variable C. Looks like we're moving along, okay. Multiply Q times P, double the result, then raise what you have to the 5th power. So we're going to double the result and then raise it to the power. Very important. You, when you do this and you raise it to a power, you have to put everything inside parentheses. It says multiply Q times P, then double the result, and then raise it the entire amount to a power, to the fifth power. A very common mistake would be to do this. I'm going to write it out and put the wrong answer here. A lot of people are going to say, oh, Q times P, and then I'm going to double it, and then I'm going to raise what I have to the fifth power. Now, this would be wrong because what would happen is that you would multiply the Q times P, but then when you took the fifth power, it would be next, and the final thing you would do is multiply by 2. It's very important that the 2, Q, and P that you want to raise to the fifth power are all inside the parentheses. Order in multiplication doesn't matter. That's because of the commutative property of multiplication. It says that you can multiply in any order. Raise D to the fourth power. D to the fourth power. Then multiply C by the result. Then divide what you have, the whole thing, by B. So we have C times D to the fourth power divided by B. Now the thing is that the D to the fourth power doesn't have to be in parentheses because D to the fourth comes first, then you would multiply by the C according to order of operations. Also, this division line, if you use it, means you don't have to have the parentheses around the entire numerator. So if I wanted to write this in a little simpler form, I could write the fraction. I have C times D raised to the fourth power in the numerator, and in the denominator, I'm dividing it by B. Multiply C by the result. This is correct. Raise D to the fourth power, multiply C by the result, which is what I did, then I divide by B. Multiply A by 6, triple the result, then multiply by 2 by what you have. Okay, basically you want multiply A times 6. That is 6A. Oops, put an extra parenthesis. There we go. 6A, triple the result. That means multiply by 3. Then multiply 2 by what you have. So all of this really belongs in parentheses, and then we're going to multiply it by 2. It doesn't matter because of the commutative property of multiplication, but it's better to have the parentheses here. And I'm doing this whole thing. So let me put parentheses inside. I'm going to take A times 6, and then I'm going to multiply that. Sorry, come on, get in there. Doesn't want to get in. There it is. Triple the result of A times 6, and then multiply by 2. It says don't simplify any part of the expression. So this is really correct. I could have gotten away without putting the extra parentheses though. Raise 5 to the second power, add the result to P, then subtract what you have from 7. So all of this is being subtracted from 7. Because subtraction is such a low level on order of operations, everything else has to be in parentheses because you have to do all the other stuff first and then subtract it all from 7. Now I have to take 5 to the second power, and then I have to add the result to P. So really I'm supposed to take P plus 5 to the second power. And then I'm supposed to subtract what I have, which is the result, that goes into parentheses, from 7. See it? Divide 6 by m. I'm going to go ahead and write it in here for you so you can see it. I'm going to take 6 and divide it by m. Raise the result to the 10th power. Then subtract what you have from 2. So you don't take 2 away from that. You take the result away from 2. So it looks like this. It's probably a good idea to write it on a separate paper before you start typing it in. It's a lot easier that way. So now, get rid of this. I'm going to take 2, subtract, and the rest goes in parentheses. I have 6 over m. And I am raising the whole thing to the 10th power. Now, really, it's actually appropriate to put this whole thing, this whole thing inside parentheses. But because this 10th power is so powerful in order of operations, I'm definitely going to take the 10th power before I do the subtraction. So this is actually more correct, and I probably could have just put the parentheses around the whole thing. But I think I'll leave it as it is. It's okay. It's not wrong. It's just not absolutely complete. All right, another one. Add u and v. So I'm going to add u plus v. I'm going to leave it open here. Subtract the result from t. Then triple what you have. Now this time it is really important that you have parentheses around the entire expression and that you have parentheses around this part as well. Because without the parentheses, if you put 2t minus u plus 7, you get a different answer. Take a look. T minus u plus 7 is different from this. It's not the same thing. So you definitely don't want to do that. You want to have this whole thing right there. So let's take the 3 parentheses t minus parentheses u plus 7. And there we have. And I have now tripled everything. I've taken the result from t. Yep. What? Why did it get it wrong? Oh, they wanted me to use the brackets instead of the parentheses. Okay, so when you use double parentheses, they require that you use the brackets, like basically like I did before. So watch out for the parentheses. You see that I have the right answer. It's just with the wrong grouping symbol. Raise 10 to the 4th power. Triple the result. Then add what you have to k. So it should look like this. I am going to include the parentheses this time. So I've got k plus 3 times the parentheses. Again, you don't have to put the multiplication symbol. You could just put the parentheses. I could do just this. Oops. You didn't have to put the times there. 10 raised to the 4th power. Practice using the little symbols and the fraction bars and so on. Double Q to Q. That's doubling Q. Multiply S by the result. So we're supposed to take S and multiply it by the result of multiplying 2 times Q. Then add R to what you have. Now, it's not wrong to do it this way because we know we have to do the multiplication before we do the addition. However, it is actually saying this in the problem. So I'm actually going to do it right this time. So we're going to put it in there. Oops, I didn't need to include the dot. Let me get rid of that real quick. I sometimes forget to turn off the pen. So I've got, oh, they didn't give me the other grouping symbol. So I'm not going to be able to put it in that way. So I am going to have to use S parentheses 2Q plus R. Of course, the brackets are more correct, excuse me, but this is the only one that they're going to allow me to put in. All right. Add 6 to F. Let's do that. Let's add 6 to F. Sorry, almost was going to write it wrong. F, that's adding 6 to F. Notice that it does matter which way you write it. Just like when you subtract 6 from F, you need to write it in the right direction. Add 4 to the result. That means that I'm going to add 4 to the result of that addition. Then I'm going to subtract 3 from what I have. Just like that. That's really what this says. So let's see if it allows me to. Interesting. I only have, I'm going to see if it'll allow me to put in the brackets and write it correctly. Let me get rid of my dots here. Okay, so parentheses, parentheses, F plus 6. Inside these other parentheses, I have a plus 4. And then I'm going to subtract 3 from the entire result. From subtracting 3 from it means, let me get rid of that dot right there real quick here. There we go. Looks a little better, hopefully. Subtract T from R. There it is. Watch out. This is very common. A lot of people want to put T minus R. That's not correct. You're taking subtracting T from R. That's what it means when you subtract T from a number. Then divide the sum of S and U by the result. So we're going to divide the sum of S and U by the result of R minus T. Now there really are parentheses around these, but because of the division line, it's assumed to have parentheses. So in algebra, we usually leave off the parentheses and just put the division line. Another really good reason to not use those sideways division, sometimes you have to. So like if you were using a calculator or something, you would have to do this. And the R minus T would have to be in the parentheses if with this division line right here. If it isn't, if you don't put the parentheses around the R minus T, then it would divide it by R and then subtract T. So you have to be careful. Since we have a division line, we're good to go. So, oops. I've got fraction, and in the top I have S plus U, and in the denominator I have R minus T. Looks like we just have 1 or 2 more. Add 4 and B. 4 plus B. Add C to the result. Then raise what you have to the 3rd power. This time it's probably going to allow me to put the brackets because they're definitely important in this case. Yep. Nope, they didn't give me the brackets again. Let me see if I can get rid of that dot. Put this away. And we've got parentheses, 4 plus B plus C, just to go inside here. Oh, I said it's inside. Come on, get in there. There it is. Plus C raised to the third power. Hopefully it likes this one. I don't see any place to put brackets, so hopefully it allows it. Yeah. Looks like I have one last one. So obviously, I've done way too many for you, but do this last one yourself. Don't wait for me. The way to do these is to pause the video, try it yourself, and then see if you get it right. Of course, the best option of all is to actually use the IXL program. And if you mess it up, of course, you can just scroll down and they'll tell you the answer. This way you don't have to take a chance on missing it, because if you miss this one, they send you back about 3 or 4 points. Divide R by S. So I'm going to take R, come on, R, and I'm going to divide it by S. I'm going to add the result of that to 3. Now, I don't absolutely have to put it in parentheses, but it does say the result. So I'm really supposed to put the parentheses around the R over S. Then multiply 5 by what you have, by what I have. So that means taking 5 and multiplying it by with the result of that. Now, because the R over S is a division and division comes before addition, it's okay to do this. Just be careful. It really does include parentheses in the expression, but let me do this real quick. There we go. So I've got 5. And again, I don't have to put the dot. I can just put the parentheses. 3 plus, I've got a fraction. I've got R over S. And that was my last one. So I hope you all got this really well and that you mastered it. Writing expressions is really important, writing variable expressions. It will help you a lot when you're doing word problems. Okay, good luck, guys. See you next time. And we got our medal. Yay! It took us forever, of course, but there you have it.